Question 44, North Carolina Math 1 released items, calculator active. Select, click each situation that can be modeled with a linear function. Pause the video and try it on your own. There's going to be a couple of them probably. Okay, so let's go over this. 3, 2, 1, boom. Now we have 5 options here. So we want to pick the ones that represent a linear function. So a linear function is going to be modeled by a line, of course. But what it means is you have a constant rate of increase or decrease. So if I look at this choice here, a taxi charges initial fee of $2. So I start with $2. And for $1.50 for each additional mile. So this would be like $2 plus $1.50 for each mile. You can actually rearrange that and do something in the form of y equals mx plus b. So that would be a constant rate of increase, $1.50 each mile. You're adding $1.50 on for each mile you take. That's linear. The population in a town decreases by 15% each year. So anytime you're dealing with percentages, you're talking about growth or decay with percentages, that's going to be exponential, not linear. What that'll look like is you'll have some starting population. But then because it's decreasing, you're going to have parentheses 1 minus 15% is 0.15 as a decimal, 0.15 raised to some power. So we'll call that power y for year. That's an exponential. So that's not going to be linear. Option C, an airplane flying at an altitude of 33,000 feet descends at a rate of 20 feet per minute. Again, I have 33,000 as my starting amount. Descends, so it's going down. So 20 feet, so minus 20 feet per minute. So again, that's going to be a linear function. It's got a constant rate of decrease. So that'll work. Option D, a pizza restaurant charges $5.50 per pizza. Boy, I wish I could buy one from a pizza place that cheap. And 50 cents for each additional topping. So again, that's going to be $5.50. And you're going to add 50 cents for each additional topping. So we'll call that T. Again, that's a constant rate of increase, 50 cents each topping. So that's going to be linear. And the last one, a cell doubles in size every 2 years. So that's just going to be like some starting amount times 2 to the hour. So the h power, or whatever your variable is. And that's going to be exponential again, because that's doubling. So anytime you're dealing with doubling, tripling, or cutting in half, or dealing with a percent increase or decrease, those are exponential. So this one's going to be linear. And actually we have 3 options here. This one, and that one.